Okay, so this is a topic about remainder theorem. Now, to easily understand this one, let us first have a simple um, quick recap about division. So let's say we have here a fraction form. We have numerator and then denominator. And the value we get here is actually quotient, and sometimes we also have remainder. Now, in a typical elementary class, we have this form, numerator divided by denominator. We get the quotient plus the remainder. Now, the remainder theorem is a way for us to, or a technique for us to determine and calculate what is the remainder of the said division. So, according to this theorem, if we multiply the quotient by our divisor plus the remainder, we get the numerator. Okay. Now, if we want to know the value of the remainder, then clearly what we should do is make this part of this equation equals to 0. So we want to make this term end up to 0 so that our r will be known. Okay. Let's say, for example, we have this function. Let's say we have a function f of x, which is equals to 9 minus 3x plus 5x squared plus 6x cubed. Okay, so this becomes our numerator, and our denominator will be 3x minus 2. Okay, so we have f of x and then divide by d. We want to know what is the value of the remainder. Okay, now, so this becomes the quotient times our divisor plus the remainder should be equals to f of x. That's the remainder theorem. Now, again, so we want to make sure that this ends up to 0. Now, if you could see, the only way for this one to be 0, focusing on the divisor, is that we want to make sure that this part ends up to 0. Okay, plus r equals to f of x. So we want to make sure that the value of this becomes 0. So 3, okay, let me write that one. We want to make sure that the divisor ends up to 0. So how do we do that? So we get the value of the divisor, which is 3x minus 2 minus 2 equals 0. So 3x, move negative 2 to the right side, this becomes positive 2. Then we divide both sides by 3. So we have x equals 2/3. So to make our divisor ends up to 0, we have to substitute 2/3 to our x. Okay, so let us continue. So q here will be 3, 2/3 minus 2 plus r. Now instead of x, we have to substitute 2, 3 to that function. So look, this part, this term ends up to 0. So 0 plus r equals f 2, 3, and what's left is that 0 times any number is 0. So our remainder can be found by this equation, the function substituted by x is equals to 2, 3. Now our numerator, which is f of x, is actually equals to 9 minus 3x plus 5x squared plus 6x cubed. So now to get the remainder, we have to substitute 2/3 to our x in that function. So this become 9 minus 3 2/3 plus 5 2/3 squared plus 6 2/3 cubed. So this becomes 2/3 is actually equals to 9 minus, well, this is just minus 2 plus we have here 5 4 9 plus 6 2 to the power of 3, that should be 8. We have 3 to the power of 3, that should be 27. Okay, so they have here r f 2/3. We have here 7 plus 20 over 9. We have here 48 over 27. We get 11. So this is our remainder. And that's it. That's how we use remainder theorem to solve for the value of the remainder. It's very easy. Okay, so we have here another sample problem. So if this numerator is divided by, let me use another color. If this numerator is divided by this one, we get a remainder of 16. Okay, that's the remainder. Now if we divide the same numerator by a different denominator with this one, then we get a remainder of 10. Now the problem asked us to solve for the value of the constant b, this one. What's the value of that? Let us first understand how we will going to solve this problem. Now for condition number one, based from the remainder theorem, we have the quotient, and then 2 minus 2 plus r, and then that should be f2. Okay, but we are given that the remainder here is 16, so we get that this is actually end ups to 0. So we left with 16 equals to f of 2. That's for the first condition. So let's do that one. So our f of 2 of this function, so x will be equals to 2, so 2 to the power of 4 plus a 2 to the power of 3 plus 5 2, put this one, to the power of 2 plus b 2b plus 6, and this must be equals to 16, should be equals to 16. Let's continue. So 2 to the power of 4, we get 16. So 16 plus 2 to the power of 3, that's 8. So we have here 8a plus 2 times 2 is 4. 4 times 5 is 20 plus 2b plus 6 equals 16. Let us combine like terms here. So we have here 16 plus 20 plus 6. So that should be 36 plus 6. We have 42. 8a plus 2b plus 42 equals 16. So we have here 8a plus 2b, well, 16 minus 42. So we get 8a 2b equals to 26, negative 26. So we leave it like that. Let's say this is our equation number 1. But this is for the first condition. Now let's proceed to the second one, where where the divisor is x plus 1. Okay, x plus 1. So let's draw a separator here. Okay, so let's proceed to the second condition. So similar to what we did with the first one, so we're going to apply the remainder theorem. So our quotient and then our divisor, that should be negative 1 plus 1, so that this becomes 0 plus r equals to f negative 1. So this becomes 0. Well, from the condition, our r here, our remainder is 10. So f negative 1. Let's continue. So f negative 1. So negative 1 to the power of 4 plus a negative 1 to the power of 3 plus 5 negative 1 to the power of 2 plus b negative 1. Okay, we're just substituting here the value of x plus 6. Okay, let's continue. So by the way, this is all equals to 10. So negative 1 to the power of 4 is simply equals to 1. For this, negative 1 to the power of 3 is just negative 1 times a. So this becomes negative a. Well, for this, that's gonna be negative 1 to the power of 2 is just negative. It's just 1 times 5, just 5, minus b plus 6 equals to 10. Combine this one, 1 plus 5 plus 6. So that's gonna be 12. So I have negative a minus b plus 12 equals to 10. So we have negative a minus b, transfer 12 to the right side, so this becomes 10 minus 12. Negative a, negative b is just negative 2. Well, we could just simply multiply both sides by negative 1, so this becomes just a plus b equals to 2. So a becomes 2 minus b. This is our equation 2. Now what we can do now is substitute this value of a to equation 1. So this becomes 8, 2 minus b plus 2b equals negative 26. So distribute, so this becomes 16, that's 16. So this becomes 16 minus 8b plus 2b equals to negative 26. So transfer 16, negative 8b plus 2b is negative 26 minus 16. So this becomes negative 6b equals to negative negative 42 is 30 plus, yes, that's going to be 42. We divide both sides by negative 6, then negative 6. So b is just 42, that's going to be 7. So the value of our uh, constant b here is equals to 7. And that's remainder theorem.